We have no idea what we're going to do in this video, but we're just going to talk about shapes, unscripted, for as long as we can. Right. Right. What is a shape?
A shape is something with any amount of dimension.
Something with...
For example, you can have
Something with what?
any amount of dimensions.
Something with dimensions.
For example, you can have 2 dimensions.
And you can have 3 dimensions. Can you have a one-dimensional shape? Or is that just a line?
You can. It is just a line.
1D and 4D. So we're gonna do most of the shapes in there because we can. Right.
You could also have other amounts of dimensions, like 0D, but that will do nothing.
Point.
No, 0D. Oh yeah.
So you can have 0D. I will draw all of the 0-dimensional shapes. A 0-dimensional shape is a shape which contains no width, no depth, and no height. It is a mathematical dot. That's it. Okay, a 1-dimensional shape. I think we should try and name some of these. Like, yeah, you can name 2-dimensional shapes. A 1-dimensional shape is a shape which contains only width, no depth or height.
It can have height, no width or depth. And
Yeah, it has one method of axis.
1 dimension.
1 dimension, hence 1D. 1D. It is a mathematical line which can be variable length. Cool. Let's get into the main part of the video because shapes are cool. Right, do you want to draw a triangle?
I will draw a triangle. A triangle is the 2D shape with the least amount of edges you can have. Because if you have 2, then it's not a shape, so it doesn't connect.
Or you can, but it'll be a mathematical line again, which is a 1-dimensional shape, as we've mentioned. So, what is a 2-dimensional shape, Daniel?
A 2-dimensional shape is an enclosed area of space with a height and a width. For example,
Does it have any depth,
triangle.
Daniel?
It does not have any depth. For as you can see, this triangle does not come out. I cannot grab the triangle or feel it. It is flat.
Flat triangle. So dull. Alright, so we've got a width, but is this the height? Or is this the height?
This dotted line is the height because it covers from the bottom of the triangle all the way to the top in a perpendicular line to the bottom.
Okay, so we can denote this by this little square here, which makes it a right angle triangle. We're making a video about shapes.
So yeah, something like dimensions.
We don't know what we're doing.
Or something with.
Do you want to step into the camera? Right. Do you have a favourite shape?
The line.
Mathematical line, that's a 1-dimensional shape.
I'll go with that one.
The mathematical line. Do you have a favourite 2-dimensional shape?
The circle
Ooh, circles.
with 12 extra sides.
So, you may notice if you have the width of a circle, like as in a triangle we have here, and we have a perpendicular line, we can have multiple different
Too
lines.
much
But
time.
that's the same with the triangle. You see the height must be the perpendicular line going from the bottom to the top.
So it would be the centre line, this middle line here. But, as you may know, these lines are exactly the same size.
Equilateral.
Pause for dramatic effect. Okay, so what we call these lines now in a circle is a diameter. Diameter. Half of it is a radius, right? So the radius is exactly half the width of a circle.
All of the points on a circle are the exact same distance from the centre, and that distance is the radius.
That's a cool fact. But if you were to attach a line, if you were to attach a piece of rope around a pivot and did have the maximum amount of distance, how would you work out how far it would go?
I've got no idea what you just said.
So if you want to work out, if you've got a diameter of a circle and you want to work out how far it goes around, we call that the circumference. The circumference is equal to the diameter multiplied by some constant that we call pi. This constant is defined by the ratio between the diameter and the circumference. What is pi roughly equal to? Do it there.
3.1415926, etc.
You seem so excited about the 5.
The 5, 3, 5, 8, 9, 7, 2, 3, ... I know more pi than you. Why are you still here?
No, it just seems interesting to see the behind the scenes process.
This is the scene. The behind the scene is a camera. Is my phone laid against the piano. Look. This might mess up the video. Breaking the fourth wall. There it is. Smile. He smiled. Right. Let's pick another shape, shall we? Let's talk about the hexagon. What is a hexagon, Daniel?
A hexagon is a shape with 6 sides.
Wow!
So,
Wait, if I may mention,
But what's the sum of the interior angles of a hexagon?
shut up! Haven't got to that yet. I'm doing a point.
Sorry.
Wait your turn. If you've done any organic chemistry, you may notice that this is the shape of circular hexane, or if we draw a circle in the centre, it signifies it has delocalized electrons and is the structure of benzene. This is not the Le Chatelier's pencil. No, not I don't know, the other one. Whatever. Hexagon, go.
So, if we label all the sides in a hexagon, 1, 2, 3, 4, 5,
5!
and 6, we can see this is the proof that there most certainly is 6 sides on a hexagon.
Hex is the Latin prefix for 6, thus hexagon. 6 polygon. It is a polygonal shape. A two-dimensional shape containing height and width. Yeah, which has 6 sides. Or, if you want to be fancy and use some fancy linguistic terms, 6 vertices, where 2 lines intersect. Like, that's a vertice, that's a vertice, and guess what? That's also a vertice. Wow. Right. Do you have any other interesting facts about the hexagon?
Where does agon come from?
Shush. Right. Moving on to another shape.
Heptagon.
They're difficult to draw. Let's draw a square, right? This is a square. All the length of the same side. We denote this with a line on a line, showing they have the same side, same length. If they weren't the same lengths, we would have, what would we have, Daniel?
We would have a rectangle. More specifically, an irregular rectangle. Because a square is a rectangle, but just a boring one.
Right, so you may notice that because these lengths are not the same side, we denote the size. We denote it by 2 lines. So we can separate them. Good old segregation. But if we have what is the sum of the internal angles in a square?
360 degrees.
Yeah, because as we mentioned before, this little thing we're drawing in the corner, a rectangle. We're drawing a little square, has 90 degrees in each corner. They're all the same angle. We've been talking about shapes for nearly 12 minutes. Let's pick another shape. Why not? Let's pick a cube. This is a 3-dimensional shape. Obviously, we can't fully render a cube on a 2-dimensional platform such as a whiteboard.
Mike Wazowski's reproduction.
You can enjoy that bit. This is a cube, as you may know it from looking in the human world. A cube. What can you tell me about a cube?
A cube is a 3-dimensional shape. This means it has height, width, and, get this, depth.
Depth. Wow, that's deep. Right. So you may notice the natural progression of some of these objects. So we have our 0-dimensional dot. I don't know if you can see that. Let's hope you can. Whatever. So we have a mathematical dot. That's our 0-dimensional object. Okay. We then move on to our 1-dimensional object. This is a line.
Which is an infinite amount of 0-dimensional dots stacked on top of each other.
Wait, hold on. Have you done repeatedly shouting horse? Is that up on YouTube yet?
No, I'm gonna upload it when I get back. Right. Then we have a square, which are 4 of these stuck together. That's fantastic. Right, so we go from that to that to that. This is we're at 2 dimensions now. We then go on to a cube. Right? Good old cubes. Ah, what a good shape. Good at containing stuff like a box. Right? Then,
Just to clarify, are they good at containing stuff that's like a box, or are they good at containing stuff like a box is? Or both?
ignoring that comment, you're taking us off course. Shush. We then draw a hypercube. Obviously, we can't do this because of, as mentioned, we can't draw a 3-dimensional cube because we only have access to 2 dimensions on this board. So we have simulated a 3rd dimension, right? By rotating it, kind of, and putting it in one frame, right? This is what we're doing with a 4-dimensional object when I try and draw it failingly. Badly, but because we often visualize the 4th dimension as time, we can only take a single snapshot of it.
I need a poo.
Thanks for shouting that to the camera. Right. So you may notice that with these progressions, we've taken one of these points and we've put another point, and we've connected them. Then we've taken another line and connected those two lines. We've taken two squares and connected each vertex. So, with a hypercube, we're going to draw two cubes, and then we're going to connect each vertex. This is a rough illustration of what a hypercube might look like if we had clever brains. Except, as you may notice, looks kind of terrible. That's because we have stupid 8 brains, and my phone is now at 80% battery. Looks kind of horrible, right? Let's take a step back and let's go into, I don't know, pick another shape, right?
Let's do a semicircle.
Oh, what a good shape, Daniel. What is a semicircle?
A semicircle is like a circle,
Like circle, or yes.
but it's cut in half. You see, if we had another semicircle here, it's sort of a circle.
It's a semi-circle. It is nearly a circle, like that. Right. So, the centre of the bottom line of a circle is going to be called the what? What are we going to call that? Centre?
Yeah, right, so.
We're going to call this C, short for centre. Be not confused with the actual centre, which would be about there-ish. That doesn't count. If we draw on this line here, right, the one that we had better before, if you pick any point on it, say there, right, or there, or even there, I mean, yeah, I'm about to blow your mind. These are all the same distance.
So how can we show that?
Visually, that has been shown. That
By drawing lines on it.
like we have done there.
And because they're all the same, they can all use one, not to be confused with this length.
That's been 17 minutes 45 seconds of talking about shapes for too long. Bye.